Hello everybody. So today is 10 of the Advent of Code puzzle challenge, and today's puzzle is about topographic map or smallest distance problem. So this is we are somewhere in lava production facility, and there's some reindeers that give us some topographic map of this lava island, and we need to find some good hiking trails. Hiking trails are the ones who are just coming from the lowest point of 0 to the highest point of 9. And hiking trails are always going up, so they never go down, and they are gradually going up, so that you can only go from 0 to 1. You cannot go from 0 to 2 or 3 or something like that. And it has to be gradual, and it has to be uphill slope. And yeah, it cannot be the just like horizontal. It has to go up in every step as well. Yes, so that is, and we need to find some trailheads. So the trailhead is that from one position to how many other hills you can go. From this example, what we can see here, you can go to 2 hills from here. So from this 0, you can go to 2 hills. From here, yeah, you can go to 4 from this 0, you can go to 4 places. You can go like that. You can go over to this 9 that is located over here. You can go to this 9 that's located over here, and you can go to these 2 9s located here. Yes. So, and the next one, it has 3 slopes. So this one is the first one. It goes 7, 8, 9. You cannot go from 7 back to 6. So this is not invalid. But from the another starting point, you can go. You have 6 and you have 7 that are going to the 2 different places. So over here, it's the total of 1 plus 2. So it's in total of 3. And yeah, and this kind of a little bit larger map, well, it's hard to see where all those trailheads are, but with this example, it's the sum is 36. So yeah, so this is the problem of today's puzzle. I just solve it right now. I don't think that I would like to solve it again. Maybe I will just tell you how did it works. So first of all, we just initialize some grid. We do a data array. We insert everything to this data array. First, we open the input file. Then we strip it. This array is just like a new array that we will append one line. And so yeah, and also I made this kind of each digit. Like in real data, you don't really need those dots because you don't have those dots. But for debugging purposes, I wanted to include those dots as well. So yes, and I also made a border around it, so I don't have that much index exceptions. And so if everything is set and done, so I can just for k in grid print k dot, I would put it like dot join k. All right. If I put it over here, then my data grid, I will just display my data grid as it is. All right. There's some problem with. So I have the elements as an int elements as well. So this joining does not like the int elements. But yeah, anyway, so I have everything just as a list of elements, and they have like this kind of border as well. So this border handles the index errors. And yeah, so this is my data, And over here I have 3 methods: generate start grid, check coordinates, and find paths. And now, yes, so yeah, how does it is? This is the extra problem. This is the shortest path problem. And how you should solve it is that you should make some kind of this kind of big grid that all the elements are some big number, and only the starting grid is like a 0 and like that. Yes, and so this is the starting grid, and it represents the index that we are checking. So in next step we are just like checking the neighboring places, and if one of those neighboring places it's 1, then we just make this 1. We point this 1 over here, but all the others are still at 1,000. And yeah, if you do it, then in next step we can just only check those values that have this 1 with them. Yeah. So this is how we do it. Yeah. So yeah. So this is the. So yeah. So first we take everything as a data object. Then we loop through all of the elements. We generate the start grid. It's just like the length of the grid, and all the elements are initialized with a 1,000. Yeah. So this is it, and then it is a total and find paths. So yes, if one element is 0, then we will just find paths. We just take the coordinates and we just take some start grid from that path. Yeah, so this is it. Yeah, maybe I will also show what's over here. So if we do it one more time, let's do it one more time. If we are in this find path methods, let me show you. Then yeah. So yeah, before we start to loop it, so we have this local variable current grid. So for this variable is that everything is set as 1,000. One element is 0, so the element is here, and yeah, it contains border as well. So yeah, this is it. And now if it's going, then it just loops through all the places. So yeah, since it has to loop, you have to search for up, down, left, and right. So I didn't want to copy the code, so I have just kind of check coordinate method. Yeah, and yes, so yeah, I just like made a method for this. Otherwise I would have to this check code. I would have to write it 4 times, and that would be bad. So yeah. Anyway, yes. So we are checking the neighboring coordinates over here. Yes, and yes. So there's what it is. New places. So yeah. So we only found one new place. It's 2 and 4. And if the other neighboring place is not valid position, then we just this check coordinate just return none. And yeah, so we will have this current places set over here. Yes, and this is it. Let me see. Yes, so it goes again. So yes, now it goes from this current number. Current number is now 2. Okay, yes. So current number that is checking right now. So yes, we are at this point number 1 over here, and then we just go and check the another number. And yeah, yeah. So this is how it works. Yes. So our this kind of data grid, it works like we want it. so that the 4s are going in every step, 5s are coming up, the 6s are coming up, the 7s are coming up, the 8s are coming up, and now we return and we got the 2 points. Yes, so this is how it works. Let me see, and if we take this bigger data, if we point it in, then it will work as well. It will work. So wait. Yes, I started to debug my input file, but yeah, I have to debug Python file. Yes, so it's 36 as the function said, and yeah, put down the real data and I got 754. And the part 2 is actually quite similar. It's just that if you have from 0 to 9, you can just like use different routes to get there. For example, in this example, you have 3 different paths how you can get from 0 to 9. And yeah, so the second part was quite similar to the first one. For my code, it was just that I needed to take out this checking, this if current coordinate y and x equal 1000. If I just like remove this this loop checking, then it worked. So yeah, so the example said that this has a value of 13, and it has a value of 13, and this for this piece of input it says what it was something 100 and it was 225. Yes, let's see how much are we gonna get. Yes, I run the wrong program. Yes, 227. All right, so this was today's puzzle. It was the shortest path problem. Well, it was a little bit hard, but I'm glad that I have studied it a little bit, so it was a little bit easier for me than the previous ones. And yeah, so that was it, and I hope you liked it, and see you tomorrow.